Hello. Today I'm going to go over Starfish Keystone Species lecture. So we're going to learn about what keystone species are and look at a particular investigation that was done to kind of discover this concept. So we start with the scientist, Robert Payne. Robert Payne was an ecologist who worked at University of Washington for most of his career. He was a pioneer in the concept of keystone species, and you see him here both as a younger scientist and then as an older scientist. He has since passed away. And working at University of Washington, he went out to the coast and was looking at ecosystems on the coast kind of as his focus. Payne regularly studied rocky coastal ecosystems with a particular interest in apex predators. So your apex predator is a predator at the top of the food chain. But one of the things that was good for studying these tide pools was that they were small enough where he could do studies on individual tide pools. On the Washington coast, Payne started to study tide pool ecosystems and the giant starfish that were the apex predator. So in these tide pools here, you'd get these big starfish, and he's got some of the starfish here that would actually be the highest predator for these different species that were living down here, things like mussels and crabs and clams and small invertebrates, things like that. Payne started a simple experiment to determine how important the starfish was as a predator in the ecosystem. So now he's saying, okay, I'm going to look at a tide pool and we're going to focus in on this apex predator, and we're going to change the conditions of the tide pool by just changing one thing. He regularly would visit the same tide pool, pry the large starfish loose with a crowbar, and toss them back into the sea. He did this over and over for 8 years. So you see an image, a recreation of him doing this where he's got these tide pools and he just has to go back regularly. Him and probably his grad students would regularly go back and remove starfish because, of course, after high tides and low tides and multiple days, some starfish would come back in. But doing it regularly was enough to change the conditions of the tide pool. He knew that there was a large food web in these tide pools, and he also knew that starfish will eat many different types of creatures. So we have an image here that has a whole bunch of different organisms that starfish might be eating. Again, you have crabs, barnacles, mussels, urchins, snails, limpets, all these different things. He did not know how removing the starfish would affect the other populations. So again, the starfish population, or removing it, is the one variable he's changing. So what you see here is just an image of some area that has a whole bunch of these mussel shells, which you can commonly find along the Pacific coast, right? After collecting and recording data for 8 years, Payne saw a dramatic change in the tide pool. The tide pool with the starfish removed was completely overwhelmed with mussels. So if this was the tide pool where he had removed all of the starfish as the predator, so these mussels had taken up almost all of the surface space in these tide pools. With no predator to check their populations, mussels outcompeted everything else and took over most available rocky surfaces. And then at the bottom here, it shows a little diagram about what a keystone species is. And here's the main thing that we want to remember. Keystone species are ones that have a bigger impact on their ecosystem. So it doesn't matter if their populations are small. If you remove that population, it completely changes the ecosystem. That's a keystone species. Or some species, if you remove the population, it'll have an effect, but not a dramatic effect, not a big effect. Eventually, this led to the concept of a keystone species. This is when the species has a larger impact on its environment when compared to its population number. All right, I hope this helps. Thank you very much.